Hello everybody and welcome back to the 18th tutorial in the C Programming with WinAPI series. In this tutorial we are going to be talking and discussing web servers and HTTP headers. So let me begin by telling you about exactly what is a web server. So whenever you try to connect to your favorite website, such as maybe YouTube, Facebook, Instagram, or Netflix, your browser basically sends a request for the content within the given URL which you're trying to navigate to. It sends this request to the web server. So this URL is understood or parsed by the web server, and then it's known to be associated with a given directory. Then the data which you're requesting from the given request is responded to you by the web server, and then your browser basically parses whatever data is sent in the response and outputs it into your web browser. So basically a web server is something that allows for connectivity of locally hosted content from your computer or a remote computer to the World Wide Web so that anybody in the world can access that content. Now, whenever a user or, for example, you requests a specific web page, most commonly that user's browser will generate something called an HTTP GET request to a given web server with a specific URI. Now, you're probably wondering what this all means. Let me start by showing you exactly what an HTTP GET request is. So I'm going to do so by bringing up Microsoft Paint. On the left-hand side, we're going to draw a box which will illustrate the user. So this is the user or the client, which is basically the browser. So the user browser. And then on the right-hand side, we're going to draw a box for the web server. So this is the remote computer which is hosting the web server that we're trying to connect to, or server. Okay? So let's say the remote computer is installed or has like a web server installed, and the web server is configured to list all of the files within a given directory. So the given directory that is configured within the web server, let's say it's C server /. So this is the directory. It's on the C drive and this folder name is server. So this server directory has some given files within it. So these are the files which we're going to be requesting. So let's say we have an index.html file, we have a users.csv file, and a profile.png file. Okay? So when the user browser tries to connect to this remote computer, let's say the IP address affiliated with this, or associated rather, with this remote computer is 192.168.1.106. So let's say this IP address is on our local network. So the user browser sends a request, oops, that was a little too long, to the remote computer. So let's say the user browser is basically another IP on our network, which is 192.168.1.104. Okay? So this IP needs to obtain the information from this IP. So it does so by generating something called an HTTP GET request. So what does an HTTP GET request look like exactly? Well, let me show you. Basically, an HTTP GET request is a request that requests a specific file from the remote IP or remote computer that we're trying to connect to or obtain information from. So a GET request starts out with the GET protocol method. So there are many different kinds of protocol methods, but the most common two are GET or POST. So what exactly is the difference between a GET or a POST? Well, I'm going to show you within this illustration. So let's start with GET. We want to get the index.html file. So we can do so by specifying the protocol method GET, followed by the URI, which is basically the path to the file which we're trying to request. So the server knows that whenever a file is requested from it, it has to get the file from this server directory. So these are all the files that it knows of. So let's say I want to generate a request to, I don't know, index.html. So I do index.html as my URI with the slash prepended to it. So now, whenever I send this request, it's going to get the index.html file. However, this request isn't done. The next part of the HTTP header for the GET request is the protocol version. Now, there are two very common protocol versions, one of them being HTTP /1.1 and the other one being 1.0. Now, the main difference between HTTP 1.1 and 1.0 is that 1.0, which was originally created, only allowed you to create a new connection for each request or response that is made. So basically, whenever a new request or response is made to or from the web server, a new connection had to be generated. However, HTTP 1.1 allowed you to use the same connection generated for the request and the response for the current call and every simultaneous call or request that's being generated. So basically here we have the protocol version, HTTP 1.1, and then we have the URI which we're connecting to, which is index.html, and the protocol method. In this case it's get, because we're trying to get the index.html file. So now the following things that we're going to specify within this request are the headers, so the HTTP headers. In our case, the most common one is host, the host header. So host basically allows us to specify the IP address that we're trying to connect to within this GET request. So host followed by a colon, which is used as a delimiter to specify when or where the actual header ends and where the content of that header begins. So host, colon, and then the host that we're trying to connect to, which in our case is 192.168.1.106. Okay? So here we have a basic HTTP GET request. We're requesting index.html at this host. So when we request this data, the web server then thinks, okay, cool, so he's requesting this file, so I'm going to return this file to him in a response. So then the web server reads this file and returns whatever content that file contains back to the browser so that the browser can output that content into basically into the white box, which will now be the generated content from the server. So this box right here that I'm drawing will show us how an HTTP response looks like. So an HTTP response actually differs from an HTTP request because the server doesn't actually specify a GET or POST protocol method. All it does is it specifies the protocol version which we're using to communicate with, which in our case is HTTP 1.1, and then the status code for the current request. So basically, if I requested index.html and that file was actually found on the web server, the status code that we would get for this is 200. Now this is by default on all web servers. Status codes are generally the same, plus or minus a few status codes that may be added by given web server coders. You know, that's to their own discretion. But by default, 200 represents that the file was actually found. And then 200 has the message OK appended to it. Or rather, a space and then the message OK, which says like, OK, the file was found. Cool. Moving on. So then we can also have like 404 not found. So let's say we send this index.html request, but index.html, for example, is actually not present on the web server. So the web server doesn't find this file. It will respond with a 404 not found message. So it'll basically look like this: 404 not found. So this would be like the response. And then basically after the response, let's assume that it's 200 OK and that index.html was found. Let's say the index.html file just had the word hello in it. So if we just had the word hello in it, the the first line would be separated by a blank space, and then after the blank space, the body of the HTTP response is specified. So let's say the word hello is all that index.html contains. So after the web server sends this response back to the user browser or client, then the user browser or client would draw the word hello on the first line of the browser itself. So basically, this is what an HTTP GET request looks like. Now, an HTTP POST request is basically the exact same thing, plus or minus a few things. So let me show you what an HTTP POST request looks like. Now, let me just erase these. Okay, so let's say we're sending a request, a POST request, to the web server. So generally, what the difference between a GET request and a POST request is, a POST request is generated whenever you try to fill out information within a form, or basically whenever you're sending information from your browser to the web server. But a GET request is basically whenever you're trying to get a specific file or page from the server. So let's have on one end you're browsing a forum and you get to a thread with multiple pages. For each of these pages, you would be requesting a specific, let me actually draw this out. Alright, so here we have our box, and then we have the GET request. So let's say the forum is forum.php, for example. The parameter that we're sending is the page. So we're sending the page parameter to the web server. So whenever it receives, like for example, page number 5, it responds with the 5th page of the web server and whatever content is appended to that page. Now obviously later on I'm going to show you guys how to code in PHP and how this data is actually obtained from the web server and how it's passed back to the client and all that. But for now, let's just assume what you see in front of you. So the user is trying to request the 5th page. The response it gets is the content of the 5th page. So basically, whenever you try to request something from the web server, you send a GET request. However, whenever you're sending information to the web server, or for example, you're sending a big content, like a message, for example, or a post that you post in a thread, you're going to send it with a POST request. The reason being is because normally a URL can only fit so many characters. Like I know, for example, in Firefox or Internet Explorer, the maximum limit of characters that you can fit in the URL bar is 2048, whereas in Google Chrome it's 32,768, I believe. Well, I know for a fact. So if you're trying to send a message, for example, that's bigger than this amount of characters, you can't fit it in the URL bar, so you can't actually send a GET request. However, if you send a POST request, it doesn't matter how big or how small the number of characters are, you can fit it regardless. But let me show you how a POST request looks. So let's say we try to send a POST request for like whatever webpage to login.php. Okay? So we want to send our username and password to the server so that it can authenticate us. So we're using the protocol version HTTP 1.1, and we're using the host header, and we're specifying our web server IP address, which is 192.168.1.106. And then the next parameter that we specify, or the next HTTP header that we specify, is something called the content type header. So this basically tells the server what kind of content it should send, or sorry, it tells the browser what kind of content it should send to the web server. So for a forum login, the most common kind of content type would be application/xwww for -form -URL encoded. And basically, this allows the browser to encode all of the requests which it sends to the web server in hex, which is basically a safe way of sending data to the web server. Okay, and then the next header that we send is content length. So we actually don't know how long the content that we're sending right now is, but here, this box is not long enough. Let me just use the eraser tool and make it a little bigger. Alright, so let's assume this box is a little bigger. Pardon my drawing skills. So let me just use the eraser tool to erase this line. Okay, so this is the post request which we're sending to the web server. So after we specify these headers within the post request, something different from the get request is that we have to specify a blank line, and then we actually specify the data that we're sending to the web server. So let's say we log in. One parameter that we're sending is the user parameter, and the user parameter is equal to white, and password parameter is equal to rabbit. Okay? So this is the data that we're sending to the web server. So the content length for this is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 22 characters. Okay? So because we're sending 22 characters, in the content length parameter, we're going to put the number 22. Now, when this web server request is sent, the web server knows to read 22 characters after the blank line, which is going to be the data that we're sending within our post request. Okay? Quite simple. And the response actually looks exactly like the GET request response. There's nothing different about it. It just basically says whether or not the server parsed the request properly, and yeah. Alright, so moving on. Let's go ahead and actually install a web server, and I'll show you guys how this actually looks in real time. So the first thing, or the next thing that you want to do, is go ahead and pull up the website apachefriends.org, and I'll actually put this website in the description below. So, or I'll put a download link to this web server in the description below. So this is the web server that we're downloading. It's called XAMPP. Rather, it's a packaged web server. So it includes Apache, MariaDB, which is basically like an SQL management tool, PHP, and Perl. So to download this, we're going to want to go to the Downloads tab at the top, look for the OS that you're using. For me, it's Windows. Then click on More Downloads, and then find the folder associated with your OS. For me, it's XAMPP Windows. Click on that. Scroll down until you see the first folder with the major version 5. For me, this has 2,391 downloads per week. So I'm using PHP 5. So this is the version of XAMPP 5.6, which includes PHP 5. Because for me, I actually learned to code with PHP 5. If you're used to PHP 7, feel free to select another folder, but for me, it's going to be PHP 5. So then you're going to want to click download. So this is going to take a little bit to download, but I've actually already downloaded it. So once the file is downloaded, you're going to get a file called XAMPP Win32 installer. So you're going to want to double click on this installer. Then you're going to get a prompt asking you for administrator privileges. Click yes, and then the installer tool will open up. The first warning will appear for everyone. It'll just tell you that your computer might have restricted write permissions to this folder. If it does, then you just have to run the installer with administrator privileges if it didn't ask you for them already. But whatever, we're going to click OK. Then we're going to click Next, and we're going to make sure that we only select a few tools here. So the only tools that we're actually going to want to install are Apache, MySQL, PHP, and PHPMyAdmin. The other ones we're just going to want to deselect because they're just useless. So we're going to click Next after that and select the folder which we want to install our XAMPP software within. So whatever, like I'm just going to install this, let's say, within server, and I've already installed it, so it's just going to say that the folder is not empty. So for you, just install, let's say, whatever folder, click unselect this unless you want to learn more about XAMPP and what it is, then click Next, and then finally click Next, and it's going to start installing the software. So I've already installed the software, so after you've installed it, you're going to get a box that pops up, which looks like this. I'm going to go ahead and select the US flag because this basically asks you what kind of language you want the software to be in. So I don't speak German. I don't understand German, so I'm just going to select the US flag and click Save. And then you're going to have this window here pop up. So this is the main control panel for XAMPP. So they made it very easy for you. You have all of your useful tabs here on the right side. And then you have the main modules which we have installed right here. So for us, it's Apache and MySQL. MySQL is the database tool, which we're not really going to be using for the sake of this tutorial, but you can choose to start it if you'd like. Once you start it, you'll get a pop-up if you have UAC turned on your computer, and this basically says that this application requires a specific port to be opened for it to operate. So the default port for MySQL, I believe, is 3306. So it basically says, like, do you want to allow this port for inbound connections on your computer? Now, don't worry, because MySQL daemon actually filters this port for you, so it'll make sure that only MySQL requests can be made on this port. So we're just going to click Allow Access, and then it's going to start, yes, on port 3306, and the process started with the PID 8872. And then we're going to actually select Apache and click Start. Now, notice for me, Apache was highlighted in red, and basically it says here that unable to start or open the process because the port 80 is already in use. So the reason for this is because I already have an application on my computer that's running with port 80, and that application is called IIS. So for me, I was using this IIS web server to code an ASP application. So this web server is actually another web server, not Apache. It's called IIS. It's made by Microsoft. I'm just going to stop this web server. But for you, it could be another application that's blocking port 80. A really common application that usually uses port 80 is Skype. So before you start this web server, make sure you turn off Skype. And then once you restart Skype, Skype will bind to another port that's not 80. So don't worry, it will still work. But just click Start now that I've turned off the IIS application. And now it'll ask you for Apache to bind to port 80. So I'm actually going to allow access, and it binded to port 80 and also binded to port 443. The difference between these two ports is port 80 is used for HTTP traffic, whereas port 443 is used for HTTPS traffic. And that's SSL, so basically encrypted and unencrypted traffic. Alright, so now that we've started Apache and MySQL, we can go ahead and open up our Explorer. So I click Explorer, and here you'll be prompted with the directory where you installed your XAMPP file, your XAMPP process. So I'm going to go to the htdocs directory, and this is basically the default directory for where our web server is going to be hosted. So by default, they already have these nice files for us here, which will allow us to learn more about XAMPP and Apache and what it is and how it works and whatnot. But let's go ahead and let me show you how this looks. So I'm going to go pull up the web server in my browser. So by default, the web server is installed in localhost or 127.0.0.1. So once I open this page in my browser, you'll see that I'm able to navigate to any of these folders within the htdocs directory. Okay? So how this is configured in the background, I'll leave that for another tutorial. But by default, this is the directory that's configured within my Apache configuration file, the HTTPD configuration file. It says the htdocs is where my root directory for my web server will be. So right now I'm in the dashboard directory of the htdocs file. I'm going to go ahead and delete all of these files because it has nothing to do with the tutorial that I want to show you guys. But so now, sorry, pardon me, when I refresh this, it'll say that this returned an HTTP 404 error. So let's actually go ahead and open up a tool, an interesting tool called Fiddler. And I'm actually, basically, this is a tool right here. It's called Progress Telerik Fiddler Web Debugger. And this allows us to see all of the HTTP requests that are sent within our browser. And it allows us to diagnose them. Very, very handy tool, actually. Where you download this tool is actually from this website called telerik.com. So I'm going to actually put a link to the download in the description, but basically it looks like this. You navigate to this page, you click download now to download Fiddler, you fill out this quick survey, basically what you're going to be using this for. You fill out your email and your territory where you're from, and then you click download and it'll download it, and then make sure you go through the installer. It's very simple. You just click install and it installs it, and then it opens it up. So basically, let me just remove these sessions. As you see already, this tool logs all of the HTTP requests that are made within your browser, within any given browser. And the interesting thing about this tool is it can also decode encrypted HTTP requests, and it does that by using something called a certificate, which is something that I'll be discussing later. So let's go ahead and refresh this page. So refresh this page. As we can see here, we made a request to localhost and the URL is dashboard. Now the result or the status code for this HTTP request is 404, which means that this URL was not found inside of our htdocs file, because our htdocs file is empty. Now, the HTTP request that got generated is right here. So these are right here. Sorry. Here we have the get request. So we're trying to get the dashboard URI or URL, and we're using the protocol version 1.1. The host is obviously localhost, and then it has a bunch of other HTTP headers that are generated by our browser. But basically, these are headers. Obviously, you don't need them. These are just generated on the fly. Now, when the web server gets our request, it parses it, and then it sends a response. And the response headers look like so. So here we have the response header, the protocol version HTTP 1.1, as you can see here. Then the status code, in this case it's 404, and the status code message, in this case it's not found. And then again, we have a bunch of other data that's generated by the web server, and then we have a useful piece of data that I actually forgot to mention before, but basically the content link, I specified this in the post request, but in the HTTP response, it actually responds with our browser respectfully so that our browser knows how many bytes it needs to read after this blank line. So this is the response. Basically everything that you see on this page here is what you see here. Okay? And then it's actually 1054 characters long, all of this. So our browser knows that it needs to read 1054 characters from here. All right? Cool. So this is basically how an HTTP header, HTTP request looks like. So now let me go ahead and pull up Visual Studio Code and show you guys how to generate. One second. Oops. So I'm going to pull up Visual Studio Code here and show you guys how to generate my own kind of neat little program or application that lets me mess around with HTTP requests. So I'm going to create a new file and then save this file in the server directory for my web server. And I'm going to call this file headers.js. So this is going to be a Node.js file. And this file, I'm going to request a router from the Express.js library. And then I'm going to make a variable for this router and call it gate, set it to router. Just ignore what I'm doing here. Right now I'm just writing a simple script so I can show you guys how to generate HTTP requests and how they look like, because we're going to be the ones controlling what appears in the response. So using my newly created gate, I'm going to make a get request, and the get request is going to be for my web server URI. The URI is going to be web server, and then whatever data here is going to be the response. And then I'm going to have a function which carries the request and the response. Let's just make it, since that's already request and response. Okay, and this function. So I'm actually writing a Node.js script, and this is something that I'm going to be explaining on in later tutorials, maybe in like a JavaScript series or something later on. But the point of this is I just want to show you guys how we're going to generate a simple request to this URI web server, and whatever data we enter in here is what we're going to get in the response. And I'm going to show you guys how that works now. So basically, I'm just going to set a status for this response as a 200 status, and I'm going to create a header, my own header, that I'm going to set in the response, and whatever data we request in the URI, it's going to output it as a response. So let's do a header called x response, and then this header is going to contain whatever data is entered inside the URI. So in this case, it's res or response. So it's going to be request.params.response. Okay, and then this gate is going to be listening on port 1337. Okay, so now, right, so I need to run this application. Oops. So I've saved this in server htdocs, so I'm going to change directory to server htdocs, and then I'm going to run this application with the Node client, and it's called headers.js. Okay, cannot find, right, so I'm just going to install the module with npm. So I'm just installing the Express module that I'm using for this test, so that I can actually, it knows where to read this module from. And now I can actually I can run the application, headers.js. I cannot find the module. Oh, right, so I installed it in the wrong directory. Did I? No, npm install. Maybe that didn't work the first time. Oh, okay, there it is now. So it's inside the Node module, so now it should work. Yep, so there we go. The first time I ran it with the G parameter, so it probably installed it in different directories. Yeah, so I ran it with the G parameter. Usually that's supposed to work. Anyways, so now the headers.js file is running. So now whenever we try to, let me pull up Telric Fiddler again and remove all of these sessions. So now, whenever I send a request to localhost on port 1337 and web server, so I'll send like the word hello. The response will be okay because I set a status of 200, and now we see here in the Telric Fiddler debugger, we'll see that the host that we requested is port 1337, and that's the port that we just binded our request to. And we can see here, okay, so right, so we can see that these are the request headers that was made and generated by the browser. It's a GET request to this URL with this protocol version. So the host is localhost 1337, and this is the response that it sends. And here we set an X response header, and we made it contain whatever data was found in the res variable. So in this case, it's the word hello. So as we can see here in the response, as you can see, there's an X response header with the data hello. All right, pretty cool. So we can actually also make our own custom responses as well. So we can use response.send request.params.res, and then, okay, that's a lot of files, a lot of applications. We'll rerun the headers.js file. So now whenever we specify the variable res, which in this case it's hello, we'll get the word hello because that's whatever we specified in our URL as the output. So if we type output here, we'll also get output as a response. So yeah, it's just pretty cool. And then in the Telric debugger, as you can see here, we sent the web server the word response in the GET request, and as you can see, the output here is output. So, sorry, we sent the word output, and the output is output, and the content length of output is 6 characters. All right, so yeah. And that basically covers everything that I wanted to talk about in this tutorial. So we basically learned about web servers, what is a web server, and we talked about HTTP headers and how to send an HTTP header and how it looks like. We debugged that with our Fiddler web debugger. All right, so yep, that covers everything for this tutorial. And again, thank you guys for watching, and please stay tuned for the next tutorial. Leave any comments or questions below, and I'll see you again next time. Thanks. Bye.